Hello, wonderful people, dear learner, dear subscriber. If you are a student of biology or integrated science, and that is all the way from grade 7 to grade 12, or all the way to Form 1, 2, 3, 4, welcome back to our lessons. We are still talking about the chapter, the cell, and I have decided that today I also set another video for you. Take this video, which is faceless. You're not able to see my face, but one thing I'm very sure 100% is you're hearing my voice clearly and that you can be able to see my handwriting on that piece of paper. As we said earlier, magnification is enlargement. And enlargement is important because we talked about specimens and especially cells that are small or minute come microscopic. You cannot see them using your naked eyes, and so we said you will use some tool, some instrument we call a microscope. Of course, we have other tools of enlargement of specimens. We have things like hand lens. These two are very common. A microscope, we said we have two types of microscopes. A light microscope, and of course an electron microscope. So we also have a hand lens, but this one we shall look at it in our next video. In this lesson, I want us to discuss about linear magnification. You should use some red pen. Linear magnification of a specimen or object when using a light, we just say a microscope. So when you're using a microscope, there is some calculation. So this is a calculation. This one is a sum you calculate. It's kind of not a sum, but is a calculation. That is like some bit of mathematics. This is now what brings the relationship between biology or science and mathematics. We'll do some calculation. Remember, we talked about one important thing that we said. We have the eyepiece, which must have some magnification. So eyepiece lens with some magnification. We also said we have objective lens, which also has magnification. So these two, the eyepiece and the objective lens, will work in combination. They will combine. So they will work in combination to bring what we call desired magnification. Now that I have said that magnification is some mathematics, I need to write the formula for calculation of magnification. So in this case, we shall say magnification is equals to I eyepiece lens magnification times objective lens magnification. Magnification is equals to eyepiece lens magnification times objective lens magnification. It is wrong, my learner, to state, some students will always say eyepiece lens times objective lens. We cannot do that. You have to indicate that it is eyepiece lens magnification times objective lens magnification. These two now, when they are multiplied, whatever you get is now the magnification. Please, when you're writing this formula, ensure the formula is correct. Avoid writing mg. Some students will write mg for magnification. This one will bring a different meaning and you lose the mark for that matter. The answer that you get, the value that you get, you write an x or times before that, before the value you get. You write x before the value you get. For example, you get a magnification of 10. So you write times 10. I will give you an example. If you get times 100, you write times 100. If you get a magnification of 400, you say times 400. These are the answers, or the way you express your values that you get after this calculation. What I mean is, times 10 means that object has been magnified 10 times to give you that image. If it is times 100, means the object has been magnified or enlarged 100 times. And of course, also, if it is times 400, then it means 400 times. Now, I go straight to giving you an example. I want to give you an example, probably the first example of our discussion today. We do an example. If the eyepiece lens has, if the eyepiece lens has a magnification if the eyepiece lens has a magnification of times 5, and the low power objective lens has a magnification power of magnification power of times 10, then the total magnification is, we put a colon. We can use another color to illustrate this. We said magnification is equals to eyepiece lens magnification times objective lens magnification. That is a mark for correct formula. if you apply it correctly, now the eyepiece is times 5. So you say times 5 times low power objective lens, which is times 10. The answer is supposed to be 5 times 10 is 50, but we said you write the times symbol for times before, or the multiplication sign before it. So that is it. And another thing I would want to tell you is this question may have 1 or 2 marks. So read properly and get to understand how to apply this formula. There is a small table that you have in KLB, a table that here we have. I will just briefly give it: eyepiece, lens magnification. This is a small table here. Then we have objective lens magnification, and of course on the other side we have total magnification. So these are very simple table I want us to discuss, and then of course come to the end of our small video. So if you have such kind of table, I expect that you are able to apply the formula and fill this table. Maybe just a few columns, 1, 2, 3. You can add another 1 row like that, Now they've started with times 5 here. And then of course there is times 4. Total magnification will be eyepiece 5 times 4, which is times 20. That is okay for the application of the formula. Then they have given us times 10 here, and of course here times 5. This one is a dash, we shall fill it. There is a dash here, then there is times 10, and of course times 100. Then there is another one for the last row. There is times 15 and times I think 40. Then there is a dash here. So these ones are dashes. Fill in the blank spaces. The first one is being used as an example. 5 times 4 is times 20. 10 times 5, you get 5 times 10 is 50. So times 50. I think this one is simply the example that we have highlighted. Sorry for that backlight problem. So this is like the example that we have done. Times 10 for the eyepiece lens magnification, times this is 5 for the objective lens magnification. The answer is times 50. Then it means this one we have to calculate. We don't have the eyepiece, we can call it E. We can call it E, the eyepiece. Then you have the objective times 10, which gives you 100. So you are looking for the value of E. So what you do, 10E is equals to 100. If you want to get E, you divide by 10 on both sides. Divide by 10, you get your E as by 10, 1, by 10, 10. So 10. So at this point, we write times 10. Meaning, times 10 for the eyepiece lens magnification times 10 for the objective lens magnification, you will get times 100. And finally, 50 times 15 times 40, you get 15 times 40, I think is 600. Let's see. 15 or 150 times 4 is the same as 15 times 40, 0, 0, 6. So I think you write times 600. So I have taught you about magnification, linear magnification while using a microscope. But before I end up this lesson, I would want to tell you this one, that when you are using a different object, for example, when you are using a hand lens, this one I will say it, although I have a lesson where I have talked about it, When you're using a hand lens for enlargement or magnification, there is also some calculation. In this case, magnification or total magnification is equals to drawing length over actual length. This one is in a different video and this one is different. This is magnification while using a hand lens. I just want you to keep this in mind, knowing that there are videos in my folders that will educate you on how to calculate this one, total magnification of an object, or when you are using a hand lens. My interest was about the microscope, and because I know we are now through with what I wanted us to discuss, please focus on the formula. And I have clearly said that the formula states magnification is equals to eyepiece lens magnification times objective lens magnification. For this lesson, I'm so glad that you've been following me. Let us meet in our next video. Thank you very much for your time, and I wish you all the best as you go on with your studies. Meet you in the next lesson. Goodbye.